In the last period, we have seen the problems of wave optics up to problem number 17. Now today, we have to see the problem number 18. Page number 185 of the new syllabus. ऑलरेडी मी तुम्हाला सांगितलं होतं की तुम्ही लोक या पानाचे प्रिंटआउट काढले नसतील तर तुम्ही त्या पुस्तकात जे PDF आहे पुस्तकाचा त्या PDF मधला पेज नंबर 185 पहा आणि प्रॉब्लेम नंबर 18. 17 पर्यंत आपण मागच्या पिरियड मध्ये झालं होतं, तर 18 नंबरचा प्रॉब्लेम काय म्हणतो ते बघा. In a biprism experiment, the fringes are observed in the focal plane of the eyepiece at a distance of 1.2 meter from the slit. म्हणजे स्लिट आणि स्क्रीन यांचा मधला अंतर जो आहे that is about 1.2 meter. ठीक है. The distance between the central bright band and 20th bright band is 0.4 centimeter. Center bright पासून 20वा bright band चा अंतर जो आहे, so that is about 0.4 centimeter. So x20b is equal to 0.4 centimeter. याला आपण 4 into 10 raised to minus 3 meter लिहिता येतं, कारण सेंटीचा -2.4 चा -1 एकूण -3 होते. पुढे when a convex lens is placed between the biprism and the eyepiece 90 centimeter from the eyepiece. आता आयपीस पासून म्हणजे आयपीस म्हणजे कोण, स्क्रीन पासून कॉन्वेक्स लेन्स किती सेंटीमीटर वर आहे, 90 सेंटीमीटर वर आहे. म्हणजे याचा अर्थ हा जो आहे दोन सोर्सेस आणि हा स्क्रीन आणि या स्क्रीन पासून हा कॉन्वेक्स लेन्स जो आहे तो 90 सेंटीमीटर वर आहे. म्हणजे हा झाला 90 सेंटीमीटर म्हणजे हे 0.9 मीटर. म्हणजे हे अंतर होईल. आता हा टोटल डिस्टन्स आहे 1.2 मीटर आहे. इथून तिथपर्यंत हा 1.2 मीटर. मग हा 0.9 गेलं म्हणजे आता राहिलेले 0.3 मीटर हा लेन्स आणि स्लिट मधला अंतर आहे. हे अंतर असतं स्मॉल डी. म्हणजे convex lens is moved towards the slit. At that time we will get the magnified images. अशी. So therefore, what they have told, when a convex lens is placed between the biprism and the eyepiece 90 centimeter from the eyepiece, आता बायप्रिझम इथं कुठतरी असतं आणि कॉन्वेक्स लेन्स इथं आहे. तर आता the distance between the two virtual magnified images is found to be 0.9 centimeter. यांचा मधला जो अंतर आहे ते 0.9 सेंटीमीटर आहे. म्हणजे आपण याला म्हणूया U, याला V, याला D1 म्हणा, हा D आहे. So they have given D1 is equal to 0.9 centimeter. That is equal to 9 into 10 raised to minus 3 meter. U is equal to 0.3 meter. V is equal to 0.9 meter. So first of all we have to find out the small d. Small d काढावं लागेल आणि small d काढल्यानंतर काय म्हणतं, determine the wavelength of the light used. लॅम्बडा किती आहे. So the formula we have to use is distance of the 20th bright band. You know that distance of the nth bright band xnb is equal to n lambda capital D divided by small d. So therefore, x20b is equal to 20 lambda capital D divided by small d. So x20b is 4 into 10 raised to minus 3. Therefore, we have to find out first of all small d. How to find out the small d? Use the conjugate foci method. Size of the image upon size of the object. Size of the image d1. Size of the object d. Distance of image v. Distance of object u. Size of the image upon size of the object. Distance of the image upon distance of the object. Using this conjugate foci method formula, we have to find out the value of small d. Small d is equal to u by v into d1. So how much value you will get? U is equal to 0.3, v is equal to 0.9 and d1 is equal to 9 into 10 raised to minus 3. So point get cancels out. This 9 also get cancels out. So 3 into 10 raised to minus 3 meter is the value of small d. Now using this formula, lambda will be equal to, lambda is equal to x20b into small d, x20b into small d upon 20 capital D. So substituting the values, we will get lambda is equal to x20b. x20b they have given 4 into 10 raised to minus 3. Then small d we have found out 3 into 10 raised to minus 3 into 3 into 10 raised to minus 3. Then here 20 into capital D. 20 as it is we have to put, and into capital D is how much? Capital D 1.2. So therefore, what you will get? 4 will go into 25 times and lambda is equal to 3 into 10 raised to minus 6, minus 3 minus 3 minus 6, and 5 into 1.2 is 12 5 is 60 means 6. So therefore lambda is equal to 3 by 6 means 0.5 into 10 raised to minus 6. So lambda is equal to 5000 into 10 raised to minus 10 meter. So finally you will get 5000 angstrom. So the wavelength of the light used is 5000 angstrom unit. Okay, this is the solution of problem number 18. Okay, so see carefully and write in your notebook. Already you have written 17 problems up to now of wave optics new syllabus. Then write down the 18th problem. First of all, you have to write down the problem and then write this solution. You also have to draw the figure there so that you can easily understand how to find out the value of small d using conjugate foci method. Okay. Now we'll go for problem number 19. See. So after this, we'll go for problem number 19. Nineteenth problem. So what does it tell? Now this is depending upon the Fraunhofer diffraction. And you know that diffraction due to a single slit we have seen. Diffraction means bending of the light at the sharp corners of the obstacle. Diffraction pattern consists of central maxima and alternate minima of maxima of the diminishing intensity. And in case of the interference pattern, you will get alternate bright and dark band. You see? Here, in the Fraunhofer diffraction by a narrow slit, the screen is placed at a distance of 2 meters from the lens. Again, capital D, 2 meters. Then, To obtain the diffraction pattern, if the slit width is, split width we can take it as A. A is equal to 0.2 mm. That means 2 into 10 raised to minus 4 m. And the first minimum is 5 millimeter on either side of the first minima is 5 millimeter on either side of the central maxima. And x first minimum is equal to 5 millimeter. So that will be here, you can say minima. 5 into 10 raised to minus 3 meter. Then find the wavelength of the light used. Lambda is equal to omega. You know that to find out the wavelength, the condition for the minima is A sin theta is equal to n lambda. And for the maxima, A sin theta is equal to 2n plus 1 into lambda by 2. Now here, you know that the diffraction pattern consists of central maxima and alternate minima and maxima on the either side with diminishing. This is the slit. Here, the screen. Now, after diffraction, bending of the light, you will get the what is called as a central maxima and alternate minima and maxima. Though diffraction pattern is like this. They have given this distance as x1 and the total distance is width of the central maxima. So width of the central maxima W is equal to 2x1. So 2 into minima, 2 into 5 into 10 raised to minus 3 meter. So 10 into 10 raised to minus 3 meter. This is nothing but the 10 raised to minus 2 meter. We call it as the width of the central maxima. This distance is capital D. Then this is a small a, width of the slit, small a. Therefore, you know that the width of the central maxima is given by W is equal to 2 times lambda. Here, how to find out condition for the minima? A sin theta is equal to n lambda. So for the first minima, A sin theta is equal to 1 lambda. So sin theta is equal to lambda by A. Now sin means here, this is the angle. Angle is equal to arc upon the radius d. So sin theta is equal to arc is x1 upon radius is d. So equate them. So we'll get x1 is equal to x1 upon capital D is equal to lambda upon A. So x1 is equal to lambda capital D upon A. But width of the central maxima is given by W is equal to 2x1 or 2 lambda capital D upon A. You can also take directly x1 also. By taking the value of x1 also, you can do the problem. Or by taking the width of the central maxima, also we can do that problem. So therefore, using this formula, what you will get here, lambda is equal to W into A upon capital D. Lambda is equal to W into A upon capital D. So what is the value of W? We have found out 10 raised to minus 2. A, what is the value of A? 2 into 10 raised to minus 4. and capital D, they have taken 2. So again this 2 to get cancelled out, you will get 10 raised to minus 6 meter. So from this, in the book, they have given the value as 5,000. How you will get the 5,000? Here, they have given the value of as a 5,000 angstrom. So that means they have given the distance between the first, whatever, if the slit is width is 0.2 mm and the first minimum is 5 mm on either side. That means they have given the value of this first minimum on either side. The distance between them totally as 5 mm. That means this is the value they have given as 5 mm. W itself they have given as 5 mm. So when you take W itself as 5 mm, so directly we have to take the value of W minimum is equal to 5 mm. That means here, instead of taking the value of what is called as W as 10 raised to minus 2, this is not W, because in the question itself they have given the value between, or the distance between the two minimum on either side of the central maxima is 5 mm. That means W is equal to width of the central maxima itself 5 mm. So directly you can find out the lambda. That means here no need to use this width of the central maxima. Directly you have to use as they have given W is equal to here 5 into 10 raised to what is called as minus 3. So instead of taking this x1 is equal to this much, that means we have to take the value of W, that is equal to width of the central maxima. W is equal to 2x1, that is 2 into here, that is directly W they have given is equal to lambda capital D divided by small a. Therefore, lambda is equal to W into A by D. The value of W itself as 5 into 10 raised to minus 3. The value of W itself you have to take it as 5 into 10 raised to minus 3 into A. 2 into 10 raised to minus 4 divided by capital D as 2. So this 2 to get cancels out. 5 into 10 raised to minus 7 meter, and that is 5,000 into 10 raised to minus 10 meter, that is 5,000 angstrom. So remember, initially I have thought that they are given the value of x1, but here the distance 5 millimeter is nothing but, in the problem read carefully, that first minima is 5 millimeter on either side of the central maxima. On either side of the central maxima, the first minimas are 5 millimeter apart. So that's why this is nothing but x1 will be 2.5, then this x1 will be 2.5, and the total will be 5. So W is equal to 5 mm. So we have got 5,000 angstrom. This is problem number 19. Okay. Now, after this, so this is the condition for the minima. A sin theta is equal to L lambda. So therefore, x1. So 2x1 is nothing but what is called as W. So directly they have given W is equal to lambda capital D upon A. Therefore, lambda is equal to W into A upon capital D. So W is nothing but this one, 5 into 10 raised to minus 3. A is 2 into, A means slit width, that is 2 into 10 raised to minus 4, and capital D is 2 meter. So put those values and you can simply calculate the value of wavelength lambda as 5,000. Okay. Then, after this, we'll go for problem number, that is 20. So what does the problem number 20 tells? You see here. The intensity of light coming from one of the slits in Young's experiment is twice the intensity of the light coming from the other slit. Let us suppose that I1 is equal to 2I and I2 is equal to I. Means one slit is showing the intensity 2I and another slit is showing the intensity I. The intensity of light coming from one of the slits in Young's experiment is twice the intensity of light coming from the other slit. म्हणजे जेव्हा यंग्स एक्सपेरिमेंट मध्ये दोन स्लिट असतात, असे S1 आणि S2, आणि हा स्क्रीन आहे जिथे इंटरफेरेन्स पॅटर्न पाहतो, तर एका स्लिटची इंटेन्सिटी दुप्पट आहे दुसऱ्यापेक्षा. ओके, आणि स्लिटची इंटेन्सिटी दुसऱ्याची समजा I धरलं तर पहिल्याची 2I असेल. ओके, देन पुढे काय म्हणते, what will be the approximate ratio of the intensities of the bright and dark fringes in the resultant interference pattern? What will be the approximate ratio of the intensities of the bright and dark fringes in the resulting interference pattern? आता रिझल्टिंग इंटरफेरन्स पॅटर्न मध्ये आपल्याला फॉर्म्युला आहे की I max आणि I minimum. ब्राईट म्हणजे I max आणि डार्क म्हणजे I minimum, याचा रेशो आपल्याला काढायचा. सो मॅक्झिमम साठी आपल्याला फाय ची किंमत किती असतं, दॅट इज फेज डिफरन्स. कंडिशन्स फॉर द फेज डिफरन्स किती असतं, दॅट इज इक्वल टू 0, 2π, 4π, 6π. and even multiples of pi is the phase difference for the bright. आणि डार्क साठी कसं आहे, odd multiples of pi, 1π, 3π, 5π, 7π, like that. So resultant intensity चा फॉर्म्युला किती आहे, I is equal to resultant intensity IR is equal to, कसं लिहिता येतं आपल्याला, that is I1 plus I2 plus 2 root of I1 I2 into cos of phi. हा फॉर्म्युला आहे. For I max, phi is equal to 0, 2π, 4π and so on. So at that case, cos phi, cos 0, 1, cos 2π, 1. So here that is equal to, for the maximum, that is for the brightness, I max, phi is equal to 0, 2π, 4π. You see here, if this is circle, here is 0, here is again 2π, here will be pi, here pi by 2, 3π by 2, like this. Here is cos 0 is 1, then here cos phi is minus 1. Okay. Next, 0, 2π, 4π, or for all this case, cos value is 1. Therefore, cos phi is equal to 1. So what we'll get, and for I minimum, phi is equal to, means for the dark bands, phi is equal to 1 pi, that is 3 pi, 5 pi and so on, So at that case, cos phi is equal to here minus 1, 1 pi, 3 pi, 5 pi, like this. That is minus 1. So when you put the values of I1, I2 and cos phi in this equation for I max and I minimum, what will get? So I max upon I minimum is equal to, what will get? I1, 2I plus I2, I plus 2 root of 2I and I into I. And cos phi is 1. And for I minimum, 2I plus I plus 2 root of, again, 2I into minus 1. So I max upon I minimum is equal to 3I plus 2 root 2I, because square root of I square is I, 2. And here this will be 3I minus, because minus into plus will be minus 2 root 2I. Again when we take the minus common, I common, what will get? 3 plus 2 root 2 upon 3 minus 2 root 2. I common get cancels out. So 3 plus 2 into 1.414 divided by 3 minus 2 into 1.414. So 3 plus, how do you get? 4 2s are 8, then 2 1s are 2, 4 2s are 8, 2 1s are 2. Again 3 minus 2.828. So that will be equal to 5.828 divided by 1. What will you get here? So you have to subtract 3.000 minus 2.828. What will 10 minus 8, 2, 9 minus 2, 7, 9 minus 8, 1, and here 2 minus 2, what will get here? 0. Then 0.172. 0.172. So when you look the log for this value, what will get? Log of 5.828 log of 0.172, 0 point bar 1 point. So that will be equal to 0.7655 log of 58 into mean difference 8 and log of 17 into will be 2355. So difference will be 0 because they are in the division form. Difference 0, again 0, 3, 5, 0 minus of minus 1 plus 1. Antilog of 0.53 will be 0.88. So it is approximately 34 is to 1. So the correct answer is 34 is to 1. In the problem they have asked the approximate value. What will be the approximate ratio of the intensity of bright and dark fringes in the resultant interference pattern? So it's about approximately. Okay? So this is nothing but the problem number 20. So they have given the two sources are not equally bright. One slit or one source is having intensity twice than the other. So at that time, what is the ratio of I max upon I minimum? So resultant intensity formula is this one. And for the maximum, that is for the brightness, phi value is 0, 2 pi, 4 pi, for which cos phi will be 1. And for the minimum, phi value is 1 pi, 3 pi, 5 pi, for which the value is cos phi is minus 1. So when we will put this, you will get the value of the ratio of I max upon I minimum as 34 is to 1. Now, after this, 21, problem number 21. So, after this problem number 20, we will see the problem number 21, in which a parallel beam of green light of wavelength 21 lambda 546 nanometer. So 546 into 10 raised to minus 9 meter passes through a slit of width 0.4 mm. Slit width A is equal to 0.4 mm. So that will be equal to 4 into 10 raised to minus 4 meter. The intensity pattern of the transmitted light is seen on the screen, which is 40 centimeter away. That is 40 into 10 raised to minus 2 meter. What is the distance between the two first order minima? The distance between the two first order minima means if this is the screen and here if this is the diffraction pattern, that means these are the two first order minima on either side of the central maxima. That means we have to find out the width of the central maxima, how much? Directly. So that's the distance between the two first order minima means the distance between two central first minima on either side, that is width of the central maxima. So you know the formula, W is equal to directly 2 lambda capital D upon A. So 2 into lambda is 546 into 10 raised to minus 9 into capital D, 40 into 10 raised to minus 2 upon A. A is 4 into 10 raised to minus 4. So therefore this 4 will go in this 40 10 times. So this will be equal to, here 6 to the 12 to carry 1, 4 to the 8 plus 1 9 and 5 to the 10. 10 into, here minus 9 minus 2 plus 1. So 10 minus 2 means 1 minus 2 minus 1 minus 9 minus 10. So therefore minus 10 will be the numerator, minus 9 plus 1 minus 8 plus minus 2 means minus 10 into 10 raised to plus 4. So we'll get 1092 into 10 raised to minus 6 meter, or you can write it as 1.092 10 raised to minus 3 meter, and 1.092 is nearly equal to 1.1, so nearly equal to 1.1 into 10 raised to minus 3 meter, or we can write it as 1.1 millimeter. 0.1 millimeter. So this is the problem number 21. Okay. Now after this we will see the problem number 22. Okay. What must be the ratio of the slit width to the wavelength for the slit width to the wavelength A upon lambda? This is slit width to the wavelength ratio. To have the first diffraction minimum at 45 degree. So theta 1 is equal to 45 degree they have given. Now all of you know that the condition for the minimum is A sin theta 1 is equal to 1 lambda. A sin theta 1 is equal to 1 lambda. Therefore, from this, what you will get? A upon lambda is equal to 1 upon sin theta 1. So therefore, A upon lambda is equal to 1 upon sin 45. What is the value of sin 45? The value of sin 45 we have to find out like this by using the triangle 45, 45, 90. The ratio of 1 is to root 2. If the angles are in the ratio of 45 is to 45 is to 90, sides are in the ratio of 1 is to root 2. So sin 45, if you take sin 45 opposite by hypotenuse, 1 by root 2. So therefore, sine of 45 degree is equal to 1 by root 2. So A upon lambda is equal to 1 upon 1 by root 2. So A upon lambda is equal to root 2. So finally A upon lambda is equal to root 2 means 1.414. In the book they have given the wrong answer as 1.27. The correct answer is 1.414. The ratio of the slit width to the wavelength of the light. In the problem they are asked, what is the ratio of the slit width to the wavelength of our single slit to have the diffraction pattern or first diffraction minimum at 45 degree. So the first diffraction minimum is at 45 degree. If this is the slit, this is the diffraction pattern, central maxima. Here, this is the first is at 45 degree. If this is 45 degree, then this will be X and this will be D, like this. So, you know the condition, A sin theta is equal to 1 lambda. So, A upon lambda is equal to here 1 upon sin theta 1. Sin theta 1 they have given. So, you will get 1 by root 2. So, 1 upon 1 by root 2. So, the correct answer will be root 2, its value is 1.414. This is the problem number, what we call it as a 22. Now, after this, we'll go for problem number 23. The diffraction pattern observed on a screen 2.5 meter. Capital D 2.5 meter. If the width of the central maxima W1 is equal to, or W we can take it as width of the central maxima W is equal to 6 mm. 6 into 10 raised to minus 3 m. What is the slit width? If the wavelength is A1 is equal to 500 nanometer, 9 meter minus 9. A2 is how much? This is lambda 1 they have given. Means we have to find out the A1 there. A1 is how much? When lambda 2 is 50 micrometer, what is the value of A2? Slit width is how much? And third case is when lambda 3 is 0.5 nanometer, means 5 into 10 raised to minus 10 meter. What is the slit width? Okay. Now, so these three values we have to find out. Slit width, A1 when lambda 1 is 5 into 10 raised to minus 7, A2 lambda 2 is this much, and A3 when lambda 3 is this much. You know the formula for the width of the central maxima. W is equal to 2 lambda capital D upon A. Therefore, A will be equal to 2 lambda capital D upon W. Now for the first case, A1 is equal to 2 lambda 1 capital D upon W. So 2 into lambda 1, 5 into 10 raised to minus 7 into capital D 2.5 upon W is equal to 6 into 10 raised to minus 3. So 2 into 2.5 means 5. 5 into 5, 25. 25 by 6 into 10 raised to minus 4 meter. 25 by 6 means 6 4s are 24, remaining 1, 10. 6 1s are 6, remaining 4. 4 means 40. 6 6s are 36, again 40. Minus 4 meter. So in the book they have given the answer as 0.4166 10 raised to minus 3 meter or 0.4166 millimeter. This is the slit width for the first wavelength lambda 1 as 500 nanometer. In the second case, A2 is equal to 2 lambda 2 capital D divided by W. Therefore, A2 is equal to 2 lambda 2. Lambda 2 is how much? 550 micrometer. So 50 into 2 into 50 into 10 raised to minus 6. 2 lambda. Capital D is again 2.5 upon W is equal to again 6 into 10 raised to minus 3. So therefore, here 2.5 into 2, 5. 5 into 50, 250. 250 by 6 into 10 raised to minus 3. Again, 250 by 6 means again 41.66. 41.66 into 10 raised to minus 3 meter. So the second answer is 41.66 millimeter. 41.66 millimeter. Third case, A3 is equal to, again formula 2 lambda 3 capital D divided by W. So 2 into lambda 3 is 5 into 10 raised to minus 10 into capital D is again 2.5 and the W is again 6 into 10 raised to minus 3. So 2.5 into 5, that is 2.5 into 2, that is 5 into 5 into 10 raised to minus 10 plus 3 means minus 7 divided by 6. So 25 by 6 into 10 raised to minus 7. So 25 by 6 means again what you'll get, the value is 4.5. 166 into 10 raised to minus 7 meter. In the book they have given the answer as here 4 pointer. You see here, what you'll get? They are given in the book 4.16 into 10 raised to minus 4. You will get minus 4 there. You see here, what is the value of the lambda 3 they have given? Lambda 3 they have given as 0.5 nanometer. 0.5 nanometer. So 0.5 nanometer means 0.5 into 10 raised to minus 10 meter. Minus 9. So 5 into 10 raised to minus 10 meter. So 2 into 5 into 10 raised to minus 3 capital D 2.5. 6 into 10 raised to minus 6. So 5 into 5 25. 2 into 2.55 and into 5 10 raised to minus 3 will go to plus 3. So minus 10 plus 3 will be equal to minus 7. So 25 by 6 into 10 raised to minus 7. So 4.16 10 raised to here. They are given in millimeter. They are given in the millimeter. This will be in the meter. If they are given in the millimeter, we can write it as 4.166 into 10 raised to minus 4, 10 raised to minus 3 meter. So 4.166 10 raised to minus 4 millimeter. So 4.166 10 raised to minus 4 millimeter. So the first restricted bit is 0.4166 millimeter. Second one is 41.66 millimeter. Third one is 4.166 10 raised to minus 3 millimeter. This is problem number 23. Now 24 and 25. Two problems are remaining. Problem number 24. So what? A star is emitting the light of wavelength 5000 angstrom. 5 into 10 raised to minus 7 meter. Then, determine the limit of resolution of the telescope. 5. Limit of having an objective of diameter. Diameter is equal to 200 inch. 200 inch. Therefore, here 1 inch 2.54 centimeter. Therefore, capital D is equal to 200 into 2.54 centimeter. So 200 into 2.54 into 10 raised to minus 2 meter. So 2 into 2.54 into 10 raised to plus 2 minus 2 0 means 2 4 to the 8, 5 to the 10 0, carry 1 to the 4 plus 1 5. 5.08 meter. 10 raised to 0 is 1. Okay, so capital. So, limit of resolution phi is equal to 1.22 lambda upon d. What is the d? D is the diameter of the lens of the telescope, objective lens of the telescope. So you put the values directly, you will get the answer. 1.22 lambda is 5 into 10 raised to minus 7 upon capital D is 5.08. So multiply 5 to the 10 0, carry 1, 5 to the 10 11 1, carry 1, 5 and the 5 plus 1 6. 6.10 upon 5.08, 10 raised to minus 7. Now the value of the log. Log of 6.10 is equal to 0.0 0.7853 and log of 5.08 0.7058. Subtraction 13 minus 8 5, 14 minus 5 9, 7 minus 0 7, again 7 minus 7 0, 0.07 in 95, antilog is 1.2. So that will be equal to 1.2 into 10 raised to minus 7 radian. So angle we have to find out, that is in radian. Number 24. This is the problem number 24. Now the last problem of this wave optics remaining, that is problem number 25. The distance between the two consecutive bright fringes in a biprism experiment using light of wavelength 6000 is x bar, consecutive bright fringe x bar is equal to 0.32 mm. When lambda 1 is x1 bar, lambda 1 is equal to 6000 angstrom, 6 into 10 raised to minus 7 meter. But how much will the distance change? x2 bar we have to find out first of all. When lambda 2 is equal to 4800 angstrom, means 4.8 into 10 raised to minus 7 meter. So this is x2 bar you have to find out. Then here wavelength is decreasing, therefore fringe width also decreases, because x bar is equal to lambda capital D upon small d. As wavelength decreases, fringe width decreases. That means we have to find out change in the fringe width. x1 bar minus x2 bar is how much? So first of all, we have to find out the value of x2 bar. So x bar is directly proportional to wavelength lambda. X bar is directly proportional to lambda. So when we can write it as x1 bar upon x2 bar is equal to lambda 1 upon lambda 2. So from this x2 bar is equal to lambda 2 upon lambda 1 into x1 bar. So therefore x2 bar is equal to lambda 2, how much it is? 4.8 into 10 raised to minus 7 upon 6 into 10 raised to minus 7 into 0.32 millimeter. Because here no need to convert into meter, because you see, if this is in meter, the result will give the 0.32 is in millimeter, x2 bar also will get in millimeter. So minus 7 get cancelled out. 4.8 divided by 6, 6 8s are 48 means 0.8 into 0.32. So what will get? 8 2s are 16, 6, carry 1. 8 is 24 plus 1, 25, 5, carry 2. 8 0 0 plus 2, 2. So 1, 2, 3, 0.256 millimeter, this will be the x2 bar. But they are asking to find out the value of change in the fringe width. x1 bar minus x2 bar is equal to, then x1 bar they have given 0.320, we may take it as minus 0.256, 10 minus 6 4, 11 minus 5 6, 2 minus 2 0, again 0. So the answer they have given as 0.064 mm. So in this manner, we have completed the total problems of this chapter of wave optics. And also, you have to see the solved problems in the textbook. You have to see the solved problems in the textbooks. And for the practice purpose, I will give you some problems by taking the photograph and sending on the WhatsApp. So you do those problem as a homework. Okay? Now in the next period we will start the next chapter, that is electrostatics. But before that we have to do the homework problems and you have to write these 25 problems in the regular problem notebook and show me in the WhatsApp group. पुन्हा एकदा सांगतो, हे झाले 25 प्रॉब्लेम. हे 25 प्रॉब्लेम सगळे तुम्ही त्या प्रॉब्लेमच्या वहीमध्ये प्रॉब्लेम लिहून हे सोडवा. नंतर मी काय प्रॉब्लेम तुम्हाला होमवर्क देईल तो फोटोग्राफ काढून तुम्हाला ते व्हॉट्सअपवर टाकणार. ते फोटोग्राफचे प्रॉब्लेम्स तुम्ही स्वतः करा आणि नंतर ते प्रॉब्लेम सुद्धा तुम्ही त्या प्रॉब्लेमच्या वहीमध्ये सांगायचे, कारण त्याचे आन्सर सुद्धा असणार तिथं. आणि त्याच्यानंतर तुम्ही जो आहे तो पुढचा जो चॅप्टर आहे इलेक्ट्रोस्टॅटिक्स, तर तो आपण चॅप्टर स्टार्ट करूया. तो चॅप्टरची थिअरी आपण नोट्स मध्ये मी तुम्हाला टाकणारच आहे किंवा त्या थिअरीच्या वहीमध्ये आपल्याला लिहायचं. तर तोपर्यंत काही कम्प्लीट करायचं आहे आणि नंतर जे होमवर्क साठी मी 5-10 ते प्रॉब्लेम सुद्धा तुम्हाला त्या वहीमध्ये करायचे, स्वतः करायचं. ओके, आणि त्याचं उत्तर तुम्हाला ते व्हेरीफाय करायचं. ओके, सो विल स्टॉप हियर.